All right, we are going to do the log properties notes. They look like this. Remember, you can skip ahead, fast forward if you need to at any point, and I'm also posting the filled in notes. So if you just watch the video far enough to understand the properties, you should be able to pick up everything else. These properties come from the log of a base of x is the inverse of the base to the x power. These are inverses of each other. A lot of the things that we're going to do today use the property where log base a of a to the some variable, I'll just make it a p, why not? This is equal to the exponent. These would cancel each other out. They're inverses of each other. And because logs are inverses of exponents, knowing the exponential rules gives us extra properties. So when we have exponent rules like when you're multiplying like bases, we add the exponents. Well, we have a rule for log that uses the exact same property. If we have the log of some base, I'm going to make it base 3, and we have a number 3 to the third times 3 to the second. Well, we have a property that allows us to expand this logarithm into separate logarithms, log base 3 of 3 to the third. But we have to use the rule where if we multiply the like bases, then we add their exponents. So what we do when we expand this is we put an addition sign in between the separate logs. And I'm using numbers that are easy to cancel so that we could cancel out the log base 3 of 3, and we can cancel out the log base 3 of 3 here. And this answer would be 3 plus 2. There we're adding our exponents, so that's 5. So log base 3 of 3 cubed times 3 squared, which is 3 to the 5th, is equal to 5, and that's totally true. So we're using these log properties, or we're learning these log properties that use the exponential properties. So here we have the 3 log properties that we're going to use today to expand logarithms, and that's going to help us simplify things a little bit easier. So if we are multiplying two numbers, we can separate each of those numbers with their own log, same base, and put an addition sign in between. If you are dividing like bases, we normally subtract the exponents. So here when we are dividing with a logarithm, we can take the log of the numerator and then subtract log of the denominator. And then our final rule would be when we're doing power to a power, when we take a number and we have an exponent and then we raise that exponent higher, then we multiply the exponents. So here we take this exponent for the log and we multiply that exponent by whatever the log of x is. So a lot of people will take this p and just put it out front. So here we're going to use log properties and simplify if possible. There's a few different ways we could approach this question, but I'm going to just go off of the multiplication that they gave us right here. I'm going to rewrite this as log base 5 of 25 plus log base 5 of 5. So I'm using the multiplication of these two numbers to separate to two separate logs, same bases. We put the 25 with the 5. I can rewrite this as log base 5 of 5 to the second plus log base 5 of 5. That squared right here goes in front and it multiplies. So now we have 2 times log base 5 of 5 plus log base 5 of 5. Sorry, I'm going off the paper a little bit. And those will cancel. we will get 2 multiplied by 1 plus 1. So the answer is 3. I could try the second one just a different way. Instead of log base 3 of 9 times 27, maybe I'll rewrite that as log base 3 of 3 squared times 3 to the third. And we can rewrite that as log base 3 of 3 to the fifth. And then we're going to take that fifth, we're going to put it in front, and we will have 5 times log base 3 of 3. And those cancel, we get our answer, simplified answer of 5. For D, we've got log 13 over 17, and I'm looking for a base. There isn't one, so I know it's 10. So I'm going to rewrite this as log base 10 or log of 13, and since it's dividing, we subtract the logs. And we always put the one on the bottom second. And then I see if I can cancel anything. Since this is a log base 10, that's not going to cancel with 13 or 17. So this did not simplify at all. The original is more simplified, but we were able to expand it. And then the next one, log base 7 of 4 to the fifth. I could rewrite the 5 in front. I could rewrite 4 as 2 squared, but nothing's going to simplify with the 7. I could also move that 2 to the front with the 5. So I could have 10 log base 7 of 2, but nothing else really simplifies. That would be as simple as we could go on that one. Log base 5 of the square root of 5. I'm going to change the square root of 5 into an exponent. Log base 5 of 5 to the 1/2. And then I'm going to put that 1/2 in front. And then these cancel, and I get a half. And here we have log in the exponent. So I'm going to think about 16 as being, and since this is a base of 4, I'm going to think about 16 as being 4 squared. Does that really do anything for me? I can move this squared onto the 5. I can make it an exponent. I can rewrite it. We'll have 4 to the log base 4 of 5 squared, or 25. And since the base of 4 with a log base 4 are inverses, these actually cancel out. And so we get 25 for our answer. All right, when we are asked to expand, we're just going to use our log properties to expand this entire term out to as many different logs as we can. So I would start by using this division sign and make it into subtraction. So I will have, make sure I'm on the screen, log base 4 of 2x cubed y minus log base 4 of z to the 4th. Then I'm going to keep expanding. So all of this right here, these are between the 2 and the x cubed and the y, that's all multiplication. So I'm going to separate that out and make it addition. I have log base 4 of 2 plus log base 4 of x cubed plus log base 4 of y minus log base 4 of z to the 4th. All right, anytime we have an exponent on that x cubed and that z to the 4th, we want to put it in front. So I can rewrite this again as log base 4 of 2 plus log, plus, put that exponent in front, 3 log base 4 of x plus log base 4 of y minus, put that 4 in front, log base 4 of z. And that's pretty much expanded as far as you could go. If you were wanting to simplify this after expanding, could maybe make 2 into 4 to the 1/2 and have log base 4 and those would cancel, we'd have a half in this spot, but I don't really think we need to do that just for expanding. But that might be useful for a different problem that asks you to simplify. All right, this one here has a square root around the entire thing, so I'm going to need to address that first. So we'll have log base A of z to the third over xy, and then that entire parenthesis is to the 1/2 power, same thing as square root. Now we're going to take that 1/2 and we're going to put it in front. And then after we put that in front, we have log base A of z cubed over xy. And then I'm going to expand the z cubed over xy, so now I'll have 1/2 log base A z cubed, and then since it's dividing, we're going to make it subtraction, log base A of xy. That half is on everything. From there, I can move this 3 to the front. But over here, I have to separate this x and the y. But what we really have to pay attention to is that x and y are both under a division symbol. So both x and y, I might separate it to be plus, but both of them are being subtracted. So I'm just going to keep that in mind when I rewrite it. I'm going to have half 3 log base A of z minus log base A of x, and then I'm going to have minus log base A of y, because both x and y are in the denominator. And that would be as far as I could expand that out. You could distribute the 1/2 if you wanted to. I don't feel like you need to. All right, then we have some exercises in condensing. So we're going to do the opposite of what we just did right there. So I notice a plus sign here, that means multiply. I notice a minus sign right here, that means divide. And we need to go order left to right. So we'll have log, and then we'll have, well, I should probably move this 2 up to the y and make that y squared first. And then when I condense these together, we'll have x and y squared. And I'm going to move that cubed up to the z also. And then from here, we're going to subtract. So we'll have log of xy squared divided by z to the third. So that would be condensed. All right, next one, we're going to condense this down. So if the number is in front, it's going to go as an exponent. So we will have log base 10 of 8 to the 2/3 plus log base 10 of 5 squared. And we're condensing this down. Probably be helpful for me to find these answers and simplify them. So log base 10 with 8 to the 2/3, we're thinking the cube root of 8 and then that answer squared. Think the cube root of 8 and then that answer squared, so 2 squared 4. Plus log base 10 of 25. And then with plus, that means we're going to multiply, so we'll have log base 10 of 4 times 25, that's 100. And then from there, I'm going to think, 100 is a power of 10. So let me rewrite this as log base 10 of 10 squared, which cancels those out. The 2 comes in front. 2. Next one, we take that half and we put it on the 9. We take this 2, we're going to put it on the 5. And then the 1/3, we're going to put that on the 125 first. Okay, so we'll have log of 9 to the half plus log of 5 squared minus log 125 to the 1/3. And I can take 9 to the 1/2. That's the same thing as square root. So log square root of 9 is 3 plus log 25 minus log of, we take 125 to the 1/3. That's cube root. So 5. Anytime we see the addition between the logs, we condense it down to one logarithm using multiplication. So log 75 minus log 5. And then when we see subtraction, that means divide with one logarithm, log of 75 over 5. Log of, what does that do? 15? 15. And then this is base 10. So I don't think there's any more simplifying we could do. All right, this next one I've got all addition. Every single one's addition. They all have the same base, so we'll combine to one single logarithm, base A, and then multiply all the letters. So C-A-B-I-N. Log cabin. Get it? I didn't make that up, I promise. Pretty terrible. Okay, last section. This would be like a non-calculator section. You can see, well, you couldn't do it on the calculator anyway because you can't type in a log base C. But we have some information given. Log base C of 2 is approximately 0.301 and log base C of 3 is approximately 0.477. Knowing that information, we can find log base C of 9. So you want to use these properties to figure out how 9 can be made into a 2 or a 3. Well, I know that 9 is the same thing as 3 squared. And we're going to use our property that says if it's squared, or if there's a power, put it in front and multiply. So we now have 2 times log base C of 3. And log base C of 3 is 0.477. So we have 2 times 0.477. And that is 0.954. Next one, we've got log base C of square root 2. I can rewrite that as log base C of 2 to the 1/2. And we're going to move that 1/2 in front and make it multiplication. So we have 1/2 times log base C of 2. And log base C of 2 is given 301. So we've got a half multiplied by 0.301. Multiply that out and you should get 0.1505. Here we are dividing. So since we know that division is the same thing as separating those logarithms out, to subtraction. We can rewrite this and then we can just replace log base C of 3 is 0.301 and log base C of 2 is 0.477. And you could just subtract those numbers. Except for I totally switched them. Whoops. I was talking and not paying attention. All right, so log base C of 3 is actually 0.477. And this one 0.301. We subtract those, we're going to get 0.176. Last one, I'm looking at 12 and I'm thinking about 2 and 3. Let's see, log base C of 12, that would be the same thing as 3 multiplied by 4, which is the same thing as log base C of 3 multiplied by 2 squared. And then we have our 3's in our 2's, so we can expand this out. Log base C of 3 plus log base C of 2 squared. We take that 2 and move it in front. Get log base C of 3 plus 2 times log base C of 2. And then we substitute in our values that were given in the directions. Log base C of 3 is 0.477 plus 2 times 0.301. So what is that? 0.602, add them together, and we'll get 1.079. Okay, I would really encourage you as much as you can to not use your calculator on this part. I do, however, understand. I mean, they're just decimals, and you probably don't want to divide this by 2 by hand. That's fine, but we're not really doing the logs on the calculator. When you do your assignment, you've got the worksheet. I don't know where mine is. Got worksheet number 2, looks like this. And you have the rest of the class to work on it. It will be due on Tuesday. And make sure you have any questions. You just come on Tuesday ready to ask them. Thanks. Have a great day. See you Tuesday.